friends, welcome back to the channel. Today I will talk in more detail about the emulation techniques. If you have not seen the previous video regarding the emulation introduction, so I would suggest that please see that. You will find that in my channel itself, but still I will just give a brief introduction of what I discussed in the emulation introduction. So emulation has come to the market because of there are a lot of complexities has been added to the chip. There are a lot of transistors that are integrated in a single chip itself. So if you want to check the functionality of a chip with the help of simulation, it will take long time, and it takes long time. It takes few days, and even if it can take up to few weeks for a particular design to be verified through the simulation technique. And that's why the emulation thing has come to the market, because the design verification with the emulation is much faster, and you know that hardware is much faster technique by which you can do design verification compared to the software stuff. So and another thing is that if you talk about emulation it directly comes to the thinking that emulation is basically that big hardware machines that is called emulator, and these emulator machines are very costly, and only these emulator machines can be available for it really takes a lot of cost to avail this service. And so if you have a design and which is have a very complicated stuff, you cannot do with the help of simulation, or you are not sure that simulation will give you the the correct functionality checking, you can take help of this emulator. So what needs to be done with the emulation technique? Let's talk about that. So emulation is a process by which if you have a particular design, if you have a particular RTL, then you must be having some verification portion of the code, and you must be having some simulation. With the help of simulation technique, you can do the simulation of this verification stuff, and there will be some areas where actually you design things. Design is basically the functionality. Say for example, you have written a flop, you have written an adder, you have written a subtractor, etc, etc. All these are called logic. These logic blocks are basically required to be synthesized, and this logic block can only be done with the emulation technique. So in emulation, what happens that you synthesize these logic blocks and you directly pass it to the emulator, by which you can do the verification of these logic blocks. But the other portion of the circuit, which is basically the software part, that is being sent to the simulator. Simulator is basically something like software. Now you must be asking this question: is it so simple? So for example, if I have a test bench, if I have a design under test, easily I can send the test bench to the simulator, and I can send the emulation to the emulator. But it is not like that in today's RTL. These verification things and the logic things are very easily mixed with each other, and the designers is basically embed the verification code part of these logic blocks. So what happens is that there are a lot of software operation happens. I would say that it is a pre-processing where you pass a complete program or pass a complete design along with the verification construct to the compiler, and compiler, what it does is segregates what is your verification simulation block or software block, what is your hardware block, that is a logical block, passes the logical block to the emulator for processing, and passes the software block to the simulator for processing. And at the end, it happens is that if you have any intended verification things, say for example, you have added some assertion, and this assertion is being caught in the emulator, you need to go and see that what are the violations has happened, and you need to check the waveform and all these things, and then you need to do a debug kind of activity. And after fixing this RTL, again you need to do the same process of simulation through the software and emulation with the logic blocks, and at the end you will get a sign of things that okay, this chip is working perfectly fine, it has a good functionality. Now it can be passed to the next part of the VLSI design flow, and that is basically the placement, routing, and then it moves to the GDS to representation, and then it goes to the chip fabrication process. So this is something in a nutshell I described about the emulation process. Emulator are basically big machines, and it is something only done in practically for specific chips. where you know that these chips are complicated and these chips is will take a long time to verify with the help of simulation, then and only you can do this, employ this this block itself. So yeah, I think if you have a query or question regarding the emulation things, I would say that please add it to the comment section, then I will try to answer your emulation queries, and you can also ask the simulation query as well, and I will try to answer those things. And in my previous videos I have also talked about VLSI design flows. Even with that also you can ask different questions in the comment section itself. And most importantly, if you like this video, if you correlate with this video, and please respond it with your likes and with your subscription itself. Going to tell you signing off, but before that I have recently published a new book called Semiconductor for All, and that is available in the Amazon. So I would suggest that if you are interested about semiconductor, if you are interested about artificial intelligence, then you can purchase this book, and it has 25 fascinating topic about semiconductor and the latest update about artificial intelligence as well. So with that, Subhasish Chakraborti signing off.